Okay, let's go. So according to this question, it says that a plank AB has length 6 meters and mass 30 kg. Now, according to this one, the point C is on the plank with CB equals 2 meters. Okay, before we carry on, let's go ahead and draw this plank here. So let's assume the plank looks a bit like this. So just a long one. So we'll call this A and B. We know that it's 6 meters long, and what do we know? Do we know it's uniform? Yes, the plank is modeled as a uniform rod, so it is. This means that the center mass is bang in the middle, and it's of course a mass of 30 kg, so 30 g, and a distance of 3 meters away from A and B. Now we also know there's another thing at point C. So point C is 2 meters away from B, so it's somewhere around here. And let's call this C, and 2 meters away from B, so it's practically 4 meters away from A. The idea is that I'm always going to take moments around A because it's easier. Now the plank rests in equilibrium in a horizontal position on the supports A and C. So we've got supports there, meaning there's some sort of reaction going on. Now before I carry this on, I want to see if the reactions have any values. And yes, if you look at this line here, the plank remains horizontal and in equilibrium with the magnitude of the reaction at C 5 times the magnitude of reaction A. So if the magnitude at A was say R, then C would be 5 times R. Okay, that's cool. Now let's carry on where we left off. So 2 people, each of mass 75, stand on the plank. One person stands at point P, where AP is X, and the other person stands at Q, where AQ is 2X. So let's just say, I don't know, one guy is over here, yeah? So let me just change the color of this. So we got one guy X meters away, and he weighs 75 Gs. And another one, say, let's say over there. Again, 75 G, and the distance here is 2X. And now we can just resolve vertically, yeah, so resolve to find the value R and then take moments about A to find pretty much X. So let's do that. So firstly, resolving upwards, we can say that we got R plus 5R, which is 6R. And now resolving downwards, we got 75 plus 75 plus 30, which is 180 Gs. This means that R must be equal to, divide by 6, and you should get 30 Gs. Alright, so that's one bit done. Now the easy bit, well, that's easy bit. Now the next easy bit is to take moments about A. The key idea of why we take about A is that you can instantly say that the sum of all the moments going upwards is equal to the moments going downwards. And trust me, this is the easiest way if you want to just solve it without making as many mistakes, or to reduce the error, yeah? So, and another thing is, if you resolve A, we can cancel out this point, this entire force upwards, because it's at the same point, so the distance is 0, since R times 0 is 0. Now let's do this. So first things first, going to 5R, what is it? It's going to be 4 meters across, so 4 times 5R will give us 20R, and well, R is 30, so 20 times 30 is 600, so it'll be 600 Gs. Now, as for the downwards, it's going to be first things first, so X, where's my mouse? X times, what's it, 75, which will be 75 Gx, plus, if you go up to 30 G, it will be 3 times 30, so 90 G. And lastly, if you go all the way up to 75 G, it will be 2X times that, so it will be 150 Gx's. And that's cool. Now, you just tidy up and just solve for X. So, oh yeah, and you can cancel the G's as well. So every single G's can vanish. Bang, bang, bang. So yeah, subtracting 90, you get 510. Collect like term 75 and 150x gives you 225 x's. And finally, x must equal 510 over 225. And just smash it in your calculator. So 510 over 225. I got 34 over 15. And just to know what that looks like, 34 over 15, that's about 2.26 recurring. There's 6 parts recurring, yep. meters. So x is actually, so I made a fair assumption. X is just before the 30G. Okay. Okay, now this one's one of those typical state that questions. So let's have a look at this wordy problem. So state two ways in which you have used the assumptions made in modeling the plank as a uniform rod. Well, two words, uniform and rod. So as a rod, we can say that this rod is straight, as you can see, or not, my one's kind of bendy. But usually you gotta say that the rod does not bend, it's straight, it's rigid. So that's one of the major things. The second thing is the fact that it's uniform. This implies that the midpoint is actually in the center. So this is quite clear. Looking at the mark scheme, I'm going to open up as well actually, so to see more options. It states that uniform mass is or acts at a midpoint of plank. So that's quite clear. I'll take this definition. Or the center of mass is at the middle of a plank. So something that implies that uniform means, in terms of rods, that the center of the mass is bang in the center or in the midpoint. As for the rod, it just means that it does not bend, must be straight, because of course if it's bent, then the center mass could be elsewhere. Is inflexible, is rigid. I would use pretty much that the rod is straight and does not bend. Probably rigid too.